goal of today's webinar really is to cover the disaster recovery completely, not just talk about tools, products you can buy, but rather take a look from IT practitioners' perspective, what has worked, what hasn't worked, and what are good best practices coming from experience, and then talk about some practical suggestions and advice, and then talk about some tools that could help you to build the DR plan as well as monitor and enforce it. So with that, let's take a minute and talk about the webinar logistics. We would like to keep this more as a dialogue rather than a conversation in one direction. So please feel free to ask questions anytime using your Q&A box on your screens, and then we will answer those questions at the end of the webinar. You can also tweet us questions using @ZetaNet. So let me introduce the presenters of today's webinar. We have Chris Shin, VP of Products, as well as Rich Webster. Rich has a really extensive IT background, and I think I would do a poor job if I introduce myself, so let me turn over to Rich.
Thanks, Gary. As Gary mentioned, my name is Rich Webster, and I'm the IT and Operations Director down here at Zeta. Just a quick point of clarification. From a Zeta perspective, IT and operations are two different groups. The IT group itself in turn supports internal applications, internal customers at Zeta, and the operations group focuses on the external customer. What I'd like to do is thank you for spending a couple minutes with us today to talk about IT business continuity and disaster recovery planning. With any luck, some of my experiences over the years might actually help you guys out as you go forward. First, let me just tell you a little bit about my background within IT and operations. I hesitate to say this, but I started off doing server engineering work about 20 years ago, working for a company called Sun Microsystems, working on mainframes, and then worked my way over into the client-server architecture, working on early versions of Solaris. From there, I was one of the team members that actually migrated Sun off of the mainframe and onto the client-server architecture. We were one of the first companies to, in turn, have a Fortune 500 company running on a client-server architecture. For those of you that are too young to remember the mainframes, you can go and Google it and find out what those things used to be. Big monolithic machines, if you will. From there, I moved into the management ranks and was one of the first internet managers of a technical operations group, and the company was called Netscape. And from there, I moved into various director and VP roles at companies like Lycos, Telefonica Data in Miami, Shopping.com, eBay, Shutterfly, and now at Zeta. I've managed IT shops with as little as 10 people all the way up to 4,000 people, so I've definitely got a little bit of big company experience and a little bit of, if you will, startup company experience. One of my many responsibilities at companies like this has been the Chief Compliance Officer, which is just basically a fancy name for somebody that crafts policies and procedures and ensures that IT groups and operations groups follow those procedures. I've gone through the painful process of doing 5 Sarbanes-Oxley audits. I've also done 5 SSA 16 SOC 1 audits, 2 SysTrust audits, and just most recently finished our compliance, or HIPAA compliance down here at Zeta. And in all of the companies I've been with, part of what we've had to do is obviously focus on the IT business continuity and disaster recovery initiatives. So you might ask me, why are we bringing up audit experience when we're here to talk about business continuity and disaster recovery? And the answer is actually kind of simple. Both SOX and business continuity and disaster recovery require IT professionals to adhere to IT best practices. The biggest difference when you're looking at an audit versus disaster recovery planning is that one, you're in turn held to a higher authority, i.e. an external auditor, and the other one, disaster recovery, you're basically held accountable by your boss. Both require executive support, both require risk assessment, and both require risk mitigation and testing to be able to be successful in your DR experiences. In my experience, most IT professionals know what the best practices are, but that doesn't necessarily mean that we follow them all the time. For example, we all know from a backup perspective that you should need to back up your data, but how many of us actually go off and test our backups when we're done to validate that you can actually recover from that data? So today I'm going to basically go over some lessons I've learned over the past 20 years from a 10,000-foot elevation. We're not going to do a deep dive into the functional differences between, yep, sorry. Yeah, so today we're going to talk about disaster recovery like we talked about, and disaster recovery in its general sense is obviously when a site is actually destroyed, but we have to also look at the true disaster in the sense that the majority of the things that we're going to encounter as far as IT professionals on a day-to-day basis are not going to be your data center's gone down, your building's gone down. It's going to be, if you will, smaller portions of disaster recovery in the sense that we've deleted a file, a server is actually blown up, or we need to in turn recover to a different point in time from a point in time recovery perspective. So once again, from my perspective, what we're going to talk about today is just at the 10,000 foot elevation. We're not going to do a deep dive into the differences between Oracle databases and SQL databases, and we're not going to be here talking about HA clustering. Now, these are all important from a disaster recovery perspective, but once again, we're going to keep our conversation today sort of at a higher level. Our intent really today is to give you some food for thought as far as when you're working through your disaster recovery and business continuity planning and things you should be thinking about as you in turn look at your current environment and figure out the best way to fortify your environment so you don't have any outages. Disaster recovery, at least from my perspective, like I said, I've been doing this for 20 years from an IT perspective, and the good news is in 20 years of doing this from a management perspective, I've never ever had to invoke a full-blown disaster recovery plan. I've come close a couple times, but I've never actually had to deploy a full-blown plan. The bad news, I've had to invoke parts of my DR plan pretty much once a quarter because there's always something that's going to happen that in turn could cause impact to your internal or external customers. I mean, the rule of thumb from a DR perspective is be prepared for the full-blown disaster, but be ready to solve the daily disaster because that's truly what you're going to encounter on a weekly basis. If we look at Zeta as an example and just my experiences in the past 5 years I've been down here at Zeta, we've had two major network outages caused by our providers. One where we actually had the typical backhoe incident where a backhoe actually disrupted the fiber line coming into our data center. We've actually had our network go down by one of our providers in the sense that they were doing code upgrades to the edge routers, and that in turn did not go well for them. And then we've had a couple outages actually at the hosting company that we've been at, where we've actually had their breakers on their PDUs have gone bad, which have in turn brought down some pieces of our equipment. But from a Zeta perspective, even though we've had these problems out there, we have the DR, from a DR perspective, we have enough redundancy built into our infrastructure that we've never really had more than a blip from a customer perspective. I'm actually happy to say from an uptime perspective, when we look at the past 5 years, we've basically held to 5 nines availability over the past 5 years. And I think, once again, a lot of that is simply, once again, good planning and good preparation from an IT perspective. In today's environment, when we look at IT operations, 95% of disaster recovery issues can be mitigated by using technology and good planning. On the flip side of it, 5% of the DR issues are almost impossible to plan for, and thus a well-thought-out business continuity plan is essential to make sure that you don't go down and you don't impact your customers. Over the years, I've been to a bunch of disaster recovery conferences around the United States, and a couple of stories that always come to mind that sort of highlight the 5% rule I think are worth sharing. In 1990, a gentleman that I had met was running banks in Miami, one of the major banks in Miami. One of his first jobs when he went in there was to take over the IT infrastructure. What he found was that the actual bank itself had all of its infrastructure up on the top floor of the 14-story building. So his first thought was, well, he needed to get that infrastructure out of there because he was fearful of hurricanes. So what he basically did is he went to the board of directors and got them to buy off and converting their building next door. And what he basically did at that point is he converted the building next door to be what he called an IT, excuse my French, brick shit house. This was in turn developed in such a way that it had raised tile floors, it had 18-inch walls, it had no glass windows, and his whole thought there was that if he puts his infrastructure inside of that building and an F5 hurricane hit Miami, he was not going to be impacted, or he wouldn't be greatly impacted. So here we go, in 1992, Hurricane Andrew actually hits Miami, and what it actually does is it in turn takes the AC unit off the top of the 14-story building and drops it right through the roof of his one-story, quote-unquote, brick shithouse next door. So that was one example, or once again, that falls into the 5% rule. Another one was happened in 1989 and involved a 5-sided building in Arlington, Virginia. And this building had an unlimited budget and unlimited resources to do whatever it needed to do to make sure that the infrastructure would not go down. One thing they didn't plan for was a guy in a forklift. In the basement of this five-sided building, the guy with a forklift hit a water main, and in turn, the water main flooded the electrical room, and that in turn brought down the infrastructure, the entire IT infrastructure for this five-sided building. In both cases, though, they had a fully tested DR plan, and this plan dramatically reduced their downtime. The 5% of the outages you're going to encounter, at least that will require you to invoke a business continuity plan, are normally outside of the control or outside of your control, and no amount of money or planning is actually going to stop these events from happening. But a good business continuity plan or disaster recovery plan could be the difference between being down for 10 minutes versus 10 hours or 1 day versus 10 days. My definition of a disaster basically is any event that can disrupt the productivity of your internal or external customers that you support. Yeah, a 10-ton unit can actually cause dropping through the roof of your data center can cause that disruption that you're worried about. But at the end of the day, a server going down can have the same effect from a disruption perspective. Your network going down can have the same effect from a disruption perspective. Or my personal favorite is when the executive loses his board presentation 2 hours before he has to go live in front of the board, and you have to in turn scramble to recover that presentation from one of your backups. These are all, if you will, disasters, and they all require you to invoke a part of your disaster recovery plan. At least once again, from the use of technology, the first step in disaster recovery is plan on avoiding the disaster. And like I said, 95% of disasters we have out there are avoidable. You know, it's just having the basics in place. Have a second server ready to go. Have a second network connection inside of your building, so if the primary fails, the secondary will kick over. And then, you know, from a data perspective, I mean, that's normally where I see problems reside from a disaster perspective, is something happens to your data. So have a second copy of that data. Have it on tape. Have it in a different data center. Have it in the cloud. Have that copy of that data somewhere else that you can recover if you need to actually go through this process. When one starts looking at disaster recovery itself and business continuity planning, the very first step is what they call a business impact analysis. It's in a sense where you go through your applications and you figure out what you need to fortify. Now, this is one where you really need to get the executives to buy in. I mean, one, you need to in turn have them be part of the process so they help define what a mission critical application is. You don't want your site to go down and find out that you thought 5 of the 10 applications which are critical, and you fortified those 5 applications only to find out the executive wanted 1 other application. So in a sense, it's teamwork working together to in turn define what your mission critical applications are going to be. Secondly, you need to sort of figure out what your recovery or your RTO is going to be, and that's basically what is acceptable downtime. Most executives, when they start off with a business impact analysis, are going to come to you and tell you that I don't want to have any downtime, they don't want to be impacted whatsoever. But the reality is those are very expensive endeavors. You can do it, but it's going to be very costly, and I think at times that's not something the executives are fully understanding of. The next thing you need to figure out is what's your recovery point objective. I think one example comes to mind. For example, one of the companies I worked at was called Shutterfly. Shutterfly itself does the vast majority of its business in the last 3 months of the year, is creating photos, albums, things of that nature. We're probably doing, on average, well over $100,000 in revenue every single hour during that time frame. So when we look at recovery point objective and where we want to recover from, we don't want to lose any of that revenue. So from that perspective, our recovery point objective was basically 0. We wanted to bring the system back up at the moment that it crashed. So these are the things you need to work with your executives to figure out what your RTO is going to be and what your RPO is going to be. And once again, 0 downtime is going to cost you a lot of money, but that's where you need to work with the executives. You need to guide the executives. The reality is that 10 minutes to 20 minutes of downtime, in most cases, is going to be acceptable depending on what you're actually doing. So that's where, once again, you need to come to an agreement with the actual executives themselves and define what your business impact analysis is going to be. Look at defining what your mission-critical applications are going to be. Once you've got that done, that's your first step in creating a business continuity plan. We briefly touched upon RTO and RPO. Once again, just defining what is acceptable downtime, and if you go down, where do you want to recover it from? And when we start talking about databases and things of that nature, there are tricks of the trade in which you can recover back to the point that the system crashed. Once again, it just takes time and money to be able to bring that back, so you have, in a sense, 0 downtime, or loss, in Shutterfly's case, making sure that we lost 0 revenue from that perspective. The risk assessment itself, I mean, once again, that's basically where you've now defined what your mission critical applications are. So at that point in time, you want to start looking at the infrastructure itself. And so that's where the IT guys really, they've taken now the assessment from the business impact analysis with the executives, and now they're going to start looking at the actual infrastructure. From my perspective, the key thing is looking at what are your single points of failure out there. There are enough ways to, in turn, eliminate failure points by, in turn, doing certain things in your infrastructure to make sure you avoid that. I mean, once again, when we look at networks, I think is the simplest thing to look at. When you look at network infrastructure itself, you can, in turn, have dual networking links coming into your building. You can have dual network cards on your systems. You can in turn pass the fiber itself off to dual routers and dual switches. So if any one of those things goes down, it's not going to bring down your application. Servers, excuse me, is another one of the classic examples. I mean, we can, for example, all the Zeta infrastructure today has dual power supplies on it. I mean, power supplies are a thing that are going to go down on a fairly regular basis. And so by having dual power supplies inside of your system, you can avoid having a single point of failure simply by doing, just like I mentioned, putting dual power supplies in it. So the next thing you need to start figuring out is identify the risk that you control versus the risk you don't control. When we look at the operations aspect of what we do, we in turn have to partner up with a lot of companies, such as hosting companies, such as internet providers. And so you start looking at the risks from their perspective, and once again, making sure that you can try and mitigate risks in the sense that you don't control. When we talked about earlier on where Zeta was having problems with one of our hosting companies, well, once again, we had a situation where we were losing power from the hosting company from their breakers at their power distribution unit. By in turn setting Zeta's infrastructure up so we in turn have power source that goes to two different PDUs, even though they had a problem, it didn't bring down Zeta. One of the things my boss always tells me, which I find somewhat comical at times, is that 2 equals 1 and 1 equals none. And that's basically what we're talking about from a redundancy perspective. If you have a box with a single power supply on it, 1 equals none. If you have a box with 2 power supplies on it, well, 2 equals 1, because if you lose 1, you're not going down. Next one. So when we start looking at managing the risk itself, I mean, once again, now you've identified the single points of failure, and the next thing you need to do is to go through and mitigate those risks. I mean, like I mentioned, from a network perspective, and this goes back to the business impact analysis. If you're going to make a system that's redundant, you're going to need to, in turn, your CapEx and your OpEx are going to go up from that perspective. So having a single network connection coming into your building, I mean, if your executives truly want to have business continuity, then we need to, in turn, provide a second network link into the building. When we look at the systems, like I mentioned just a few moments ago, when you look at the systems themselves, look for the single points in this failure inside your system. Dual power supplies obviously being one of the key things. Having a second network interface inside of your system is key to that. When you're looking at storage itself, I mean, make sure you don't have all your storage in one particular rack that's hooked up to one power supply, for example. Spread your storage risk around. Move it over to different systems. You can have a primary system out there, but obviously have a secondary place where you're storing that data. And once again, the power aspect of it, because that's one of the main thing I see causing problems, at least in hosting that we're dealing with today, is once again, it's power issues out there. You can overload a circuit, you can have a power supply go down, you can have, like in our case, breakers go bad with the actual hosting company itself. So once again, you need to figure out ways to mitigate that risk and manage that risk. And like I mentioned at the outset, you're going to need to have a capital investment to in turn make sure that you can in turn fortify your systems. One of the other things to think about too, at least from an internal and from an external perspective, is what applications are worth hosting yourself versus what applications are worth outsourcing to somewhere else. If we take Zeta, for example, we looked at 2 key applications that in turn drive a lot of what we do down here internally, and that's our phone system and our email services. We used to host both of those services ourselves, but we realized it was better to in turn host those applications within another company because they in turn can provide the diversity that we're looking for. If we look at our phone systems, for example, Zeta used to have the phone system internally, but what we decided to do that it was better to mitigate that risk by providing or putting that in the cloud in a sense, by putting it out with a provider that in turn takes care of our phone needs down at Zeta. And what that allows us to do is that in turn now has a redundant phone system that we in a sense have Zeta's phone services are located in 2 different data centers. So in theory, one of those data centers might go down, but we still fail over to the secondary system, and that would in turn obviously keep us up and running from a sales perspective and a marketing perspective. I think one of the biggest challenges within disaster recovery is, it's like I said at the outset, it's best practices. I mean, one of the things about Sarbanes-Oxley, which is a real, it's good and it's bad, is at the end of the day, Sarbanes-Oxley, you are held to a higher authority, and that higher authority is the external audit team itself. Mm-hmm. From that perspective, they make you or force you, in a sense, to follow, best IT practices. We mentioned at the outset backups. We all know that backups need to be done. We all know that you need to, in turn, put that onto tape or into the cloud and move that offsite. But at the end of the day, you need to be able to test that. I've had several scenarios where we've actually recalled, for example, at Shutterfly, we had tape libraries that were well over 50,000 LTO tapes, and we've had to bring those tapes back in on a variety of different reasons to recover. And there's been times where we brought that tape back in, we've realized that tape didn't work. We thought that it was fine. We thought everything was good. We shipped that tape off, and then we brought that tape back in. We realized that at that point in time, it wasn't working. So that's when we started working with disaster recovery and Sarbanes-Oxley and Shutterfly. We started to actually test the tapes before we sent them off site, validate that you could actually get these things to do what they're supposed to do in the moment of crisis. When we look at networking connections, for example, we do quarterly tests down here at Zeta where we in turn will take one of our primary network feeds into the building and we will, in a sense, unplug it to validate that it will fail over to the secondary box. Now, a lot of IT guys have, it's one of two camps, if you will. One, don't want to test environment or don't want to test their infrastructure because they're worried about bringing down the actual customer base. And the second side of things, at least my philosophy, is you need to test this because you need to know how it's going to work in the moment of crisis. One classic example that I have of where somebody decided not to do testing was back some years ago when I was at Lycos. We in turn had a data center on the West Coast. Lycos itself had a search engine that in turn was split between West Coast and the East Coast. What I did, I got a call 3 o'clock in the morning, went down to the data center, and what we found is we had lost power in California. In Silicon Valley. What we found then is that the environmentals, i.e. the generator and everything, had kicked off at the data center, and so we had plenty of power, but what they didn't realize is that nobody had bothered to actually hook up the HVAC units to the generator. The data center manager at that point in time didn't want to test the environmentals with customers in there. He felt that everything would work fine, but at the end of the day, what we found is by the time the disaster had actually happened, we found a situation where they had no air conditioning inside the data center. Within a very short period of time, we had a situation where the data center itself was coming up to 100 degrees, and we were getting ready to basically take Lycos' infrastructure and flip it over to the East Coast when power came back on. But there's an example where somebody decided not to do the testing. If they had done that testing in a controlled environment, they would have been able to figure out that the HVAC was not hooked up to the generators. So once again, if you don't do your testing out there, it's going to lead to significant downtime. One of the other things that just is, it's caused me some problems in the past is you have an awful lot of documentation at your fingertips as far as your environment. Make sure you've got that documentation stored somewhere else. I mean, if it's on a thumb drive, if it's in what we used to call in the old days a run book, I mean, make sure you've got your contact information, your circuit ID numbers, your vendor information. Have that somewhere else, because if your network goes down in your office and you can't get to that data, you've just made a problem that's bad and you've made it even worse. So when we look at Zeta itself and we talk about disaster recovery and single points of failure and those types of things, I think it's, in a sense, I'll give you an overview of what we do down at Zeta. When we have, Zeta has its external customers, and from our perspective, we have dual network feeds that come into the building inside of our data center. We've got dual 10 gig links that come in from our network providers. We in turn use separate network providers because we want the network link itself to come in through diverse paths. We don't want it sharing any infrastructure. We want, once again, complete diversity as our 10 gig links come into the building. Once they come into the building at Zeta, they in turn hit 2 core routers inside of Zeta. From there, they hit dual switches. From there, they hit the dual network cards in each one of our systems. Our network itself is set up in an active-active configuration so that if something happens to any one of the components of our network infrastructure, i.e. the physical hardware, it's going to fail over. And from a customer perspective, you're not going to notice anything more than a momentary blip as far as what actually happens to the infrastructure when we lose that. As I mentioned at the outset, we've had situations where our providers have actually gone down. But once again, the situation is set up in such a way that if we lose one of our main providers, we flip automatically back over to the secondary provider, and the customer itself actually has no impact. And that's, in a sense, what we're trying to do, because that's how we're in turn hitting the 5 nines availability that we're trying to get for our customer base. We talked about storage and systems briefly as far as the power supplies. Once again, we have dual power supplies in every box. Each one of our power supplies hooks up to a different power source inside the hosting company. Once again, we've eliminated that single point of failure from a power perspective on our systems. When we talk about clustering, that's what we do with any one of our primary systems out there. Each one of our primary systems has a secondary system that's part of the cluster itself. So if one of those boxes dies on it, it flips over to the secondary box. When we talk about Zetta itself, a lot of us have heard about RAID technology. Zetta does it a little bit different in the sense we use RAIN technology. So we have a redundant array of nodes. So we in turn take that data and we strap it across multiple servers versus multiple disks in the same server itself. Once again, if we lose a box for whatever reason, it's not going to bring down the customer because we have that data spread across multiple systems. When we talk about Zetta, I mean, a lot of this, at least from our perspective, I mean, we're obviously eating our own dog food down here. We're making sure that every application, every system, every PC, every laptop has got the Zetta agent on it. So once again, from a DR perspective, we have copies of that data somewhere else. And like I mentioned at the outset, we are constantly asked, be that internally or externally, to in turn recover files for people. And by using Zetta, we're able to do that and make sure that we're taken care of. And if we lose, an executive loses a file, for example, it's something that we can recover in a matter of minutes. When we look at Zetta itself from an application perspective, we have the ability to have geodiverse replication out there. Customers can in turn have the primary copy of the data inside of their data center. And if they want a secondary copy, fine, they can put it with us out in one of our data centers in the East Coast or West Coast. And then, like I mentioned, they can also use the geodiverse application where they can actually copy that data over to a second data center on the opposite coast. So that allows you to put databases or data in multiple locations. And then once again, from a Zetta perspective, all of our databases are replicated, so if we have any problems with our actual database itself, we have a secondary database that kicks in automatically. I think when we talk about examples, I mean, Hurricane Sandy, Zetta in turn got an awful lot of requests from our customers down on the East Coast to help them recover from a data perspective when the hurricane hit. One of the most recent ones in the past 6 months was a company out in the Midwest that in turn had a rogue employee. This employee was basically was leaving the company, and on the way out the door had decided to do some stuff that wasn't very nice, if you will, and that put the company into a pinch. We got a call from the CTO of the company saying, look, this is what's happened. We were able to work with that company and recover that data that the employee had actually deleted. We've had situations where the CEO has actually lost a laptop or laptop has been stolen, where we've had to recreate that data for that CEO. And then we've actually used it, some companies have used this as a stopping point, if you will, from a data center migration perspective. Instead of buying swing gear, what they basically did is they in turn used us as a short-term stopgap to in turn store their data while they moved from California out to Utah. So once again, those are some examples as far as things that we've actually seen our customer base use the Zetta product for. We talked about this briefly. I mean, once again, one of the reasons that I like the Zetta application itself is simply because I've been burned in the past by using tapes. Tapes they're convenient. I think that's the one thing you can say about them. But the thing to realize about tapes, and if we look at tapes, I mean, specifically I'm talking about the LTO variety of tapes we have out there. I think we're up to LTO 5, if not mistaken, possibly 6. The bottom line here is that tapes are convenient, like I mentioned. They give you the ability to store a lot of data onto a tape, and they allow you to put that data on at a fairly quick speed, which is ideal for what we're trying to get accomplished. The problem is once again, the tapes are going to fail on you, and the problem is you don't necessarily know when a tape is actually going to fail. You might think that you've actually got a successful backup. You might think that your data is on that tape until you bring that tape back in. Part of the problem, especially when you look at it from an audit perspective, audits are tricky in the sense that you need to do a point-in-time recovery, and you could have to go back as many as 7 years and do a recovery and recreate an Oracle database, for example, from 7 years ago. The thing to keep in mind when you're talking about tapes is the infrastructure cost itself. So you're buying the actual software and you're actually buying the actual hardware. So you have your capital expenditure from that perspective. The second thing you need to keep in mind is that you have the support costs for each one of those things. Rule of thumb in my business is basically 20%. You're going to pay 20% support cost to in turn support that application and to support that piece of hardware. After you reach the 3-year limit on a piece of hardware, you're going to find that that support cost is actually going to go up. So from that perspective, you now have a situation where your infrastructure year over year, especially after it's amortized after 3 years, is going to actually start going up in cost. Part of the problem you have with the LTO tapes is that remember that the tapes themselves the drives themselves are increased by generation. And what I mean by that is that, like I mentioned, we'll say the word LTO5 today. Well, if you have an LTO5 tape drive today, that means you can read and write to an LTO4 tape and an LTO5, and you can read off an LTO3. The problem is if your tapes are LTO1 or LTO2, you're not going to be able to use that device to read that data. So from that perspective, you now have to keep antiquated hardware to in turn be able to recover that. So if you have a backup that's 7 years old and you have to bring it back in and you're an LTO1, well, you better have that box under support contract so you can actually recover that data. I think that's one of the beauties of Zetta itself. We take care of that cost for you. In a sense, that's part of the bundle of costs. We take care of the upgrades, the infrastructure, and that's something you don't have to worry about. And from a testing perspective, any day of the week you want to try and recover that data from Zetta, we're here to help you out. So that in turn becomes something that we become your partner in recovery when you look at disaster recovery.
Okay, thank you, Rich. This is Chris Shin. I run products at Zetta. I'm just going to take a couple minutes here at the end, not too much of your time, to try to describe how the Zetta service might be able to play a role in your overall disaster recovery planning. The Zetta solution is at its core, it's an online backup solution with disaster recovery elements for targeting mid-market to large enterprises. And it basically has 3 primary functional components. The first is the Zetta Storage Cloud, which is effectively, it's a large scaled out file system that runs in multiple domestic data centers today. All of the data stored at Zetta is stored within the United States. Now, that file system has very much enterprise-grade characteristics in terms of a very strong data availability and integrity profile with the type of RAID and RAIN encoding we have in place, as well as redundancy. In terms of data security, with everything encrypted in transit and encrypted at rest. And also, everything's been optimized significantly for WAN performance. But the way that the storage that we use to support our service presents itself out to users and to applications is using familiar file system semantics. We couple that storage cloud with an agent or a client, which is software that we call Zetta Mirror. Zetta Mirror is at its core a very WAN efficient, WAN optimized, latency tolerant file sync and replication solution. So because our storage is a file system, the Zetta Mirror views the world in terms of files and syncs files up. It's very aggressive at determining what has changed within a file set between the current sync window and the last to minimize the amount of data that must be sent over the wire to keep the backups current, etc. The way it works is using what we refer to as a reverse incremental approach. Unlike a tape infrastructure where you have to create a discrete incremental file because the initial full is stored on a removable set of media, because everything at Zetta is stored on disk, what we actually do is we take the changes that we discover in the current sync window or backup window, and we send those changes over the wire to the file system at Zetta, and we patch them into the copy we have from the last sync window to bring the file system that we have current with the file system you have locally. So in that respect, you wind up with a virtual full backup every night, but all you have to do is send the incremental changes over the WAN to us to be able to patch them in to be able to get you to that full state. The second thing that Zetta Mirror does on top of that sort of core engine of WAN efficient file sync and transfer is we actually can create backups of structured data sets and images. So Zetta Mirror has the ability to back up common applications like Exchange and SQL and images like Hyper-V, et cetera, and through this plug-in architecture, NetApp filers and so on and so forth. And that has sort of turned us into a full-featured enterprise backup set. And then the third thing that Zetta Mirror can do is it creates backups not only in the cloud at Zetta, but it also provides you a mechanism to create a local backup. So the use case here is primarily around those structured databases and images where you might have a very large set of data in one single file, like a backup of an Exchange database, for example. and you don't really want to have that a backup file only living across the internet. Now, for disaster recovery purposes, it's important that you have the offsite copy of that backup. But for rapid restore, you probably want to have a local backup of that as well. And so ZetaMirror software can provide the ability to create a local backup anywhere in the infrastructure in your LAN that you have space today. There's no appliance form factor required with Zeta. All you need to do to start working with Zeta is to push out the ZetaMirror agent to any location or server that you want to back up data from. Our third functional component is our web application that governs all of the entire infrastructure. Every customer gets their instance of our web application, which is the service management platform, and that functions as a combination of a configuration portal. It's also the portal through which you can monitor and manage your backup infrastructure, and it is also the mechanism through which the majority of our customers will recover data back from their backup set at Zeta. We have a version of the service management portal that's geared toward managed service providers, which enables our managed service providers through single sign-on to access multiple end customers simultaneously and manage all of their customers from one central location. And it's important to note that as a full service offering, a managed service offering, Zeta is sort of there with you. A lot of times when our customers want to restore a file or restore a server back online, the first thing they'll do is call us or send us an email, and we will help them work through these events as they go through them. And that is 24/7 support that's included as part of the service at no extra charge. And all of that is domestic, located within our headquarters building here. So if people actually encounter questions that they don't know the answers to, they can just walk upstairs and go talk to somebody who's actually written the code and figure out what's going on. A couple of use cases I wanted to touch on. These are actual examples of customers that recovered using Zeta as part of a disaster recovery plan. We had dozens, if not scores, of customers that were impacted by Hurricane Sandy. One in particular was unable to even reach his data center where the power was out for 10 days, and that was obviously very disconcerting to him, and he didn't know if when he got there what he was going to find. So by the time he was actually able to get to the data center, he already had in his possession a full copy of his data that we had shipped to him, that he was able to bring with him on site to make sure that anything that was missing he could get back up and running. These images obviously here are of our product, and they're showing someone browsing through their recovery set at Zeta. I should probably point out that as a file system, the recovery mechanism from Zeta is actually not so much a restore in the classic sense. It's really just a mount your file system at Zeta and browse through it. It's a fully mountable, browsable file system copy, a replica of your data set. Another example was, at sort of the other end of the spectrum, a smaller scale but no less significant, a CEO who had actually lost his laptop. Now, the majority of the users of the Zeta service are backing up their server infrastructure, but it is important to note we back up desktops and laptops as well across Mac and Windows platforms. And for the record, we also support a wide variety of Linux operating systems. But in this particular case, a very important user at this company had lost his laptop, and we were able to stream the data back down over the internet that was unique to his laptop, and by the time he returned back to the office, he had a laptop waiting for him that had his personality, so to speak, and all of his files on it. Here's an example from that's sort of a little bit more specific to the legal world. Obviously, discovery events are very common. As part of our service, we will extract mailboxes, and this usually happens for compliance reasons or discovery reasons. We will extract mailboxes for our customers on their behalf at their request and restore them back to their environment if they need to get back to a previous state of the email. And then the image here we're showing is actually, if you see the bottom of the image, the zb121.zeta.net, that's actually someone has mapped a network share that points to Zeta. That again reemphasizes the fact that it's a mountable file system. Not only can you use the web-based file browser to be able to traverse your backup set and find the files you need to restore, but you can actually incorporate it into your Windows experience through mapping a network share that points across the internet to the backup set at Zeta. so that you can browse in and extract whatever data you need. Another example here from a use case perspective is this customer had lost their server image. This happened about 2 weeks ago, and we were able to pull the server image off of our infrastructure and restore it to them so they could get back up and running in a virtual environment very quickly to recover from that disaster. From a high-level perspective, Zetta provides you the ability to back up all of your data off-site as well as locally. It allows you to archive data that you no longer need to have spinning on your disk, but you need to have mountable and accessible, and we can do that in our cloud. And it provides disaster recovery for files as well as for being able to restore databases and images. Our Zetta Mirror agent is not a chargeable agent. In its native format, it is just installable as many times as you need it to protect your data as necessary, and it comes with all the plugins that I described. Our entry-level product tier starts at 500 gigs, and that includes, of course, unlimited Zetta Mirror licenses, 24/7 monitoring support, all the plugins, all maintenance, all upgrades, etc. And that begins at $225 per month. So with that, I will wrap up this slide and then see if there are questions that have come in over Twitter or through the interface. These are the email addresses through which you can reach Rich or me. R. Webster at Zetta.net, C. Shin at Zetta.net. If you go to www.zetta.net, there's a free trial link. There's also a ton of information there about how Zetta can help you with your disaster recovery plan. And I believe upon request we have actually some templates, some disaster recovery templates that we can provide. If you reach back out to us, we can send those to you as well. So I don't know if any questions have come in, Gary.
Okay, thank you, Rich, and thank you, Chris, and let's open up for questions. So the question, the first question is how safe it is to do an online backup versus tape backup in terms of the security.
Well, yeah, I guess I'll start with that one. So security is, without a question, enhanced when you are using online backup. Everything is encrypted in transit. Everything is encrypted at rest. Certain amount of security is just table stakes in the cloud world today, and most providers will provide it for you. And everything is both logically and physically delineated when it gets to the cloud, et cetera, et cetera. Well, I shouldn't say that's not true of everybody. That's certainly true at Zetta. Whereas tapes are typically not encrypted. Tapes are potentially overly portable from the perspective that someone can pick them up and walk away with them. And once they're out of your possession, which you need to have them out of your possession in order to ensure that that you're in compliance with any off-site backup requirements for your regulations, then they're truly out of sight, out of mind. You don't have any way to verify that the data on them is accurate, and you don't have any way to verify that the data on them is still there securely stored. So I think cloud is better from a security perspective, despite perhaps some of the biases that exist in the marketplace.
Okay, thank you, Chris. The next question is, how do you handle global companies that do not want recovery data crossing regional borders?
Mm-hmm. Well, that's a great question. So today, as I said, all of the data centers that Zetta has are in the domestic United States. Most of our customers, probably 90% or more of our customers, are U.S.-based companies. We have a lot of those customers backing up international data, but because they're U.S.-based companies, the data streams into the United States for backup, and that's fine for them. In fact, it's preferred. We do not yet have international data center presence scattered throughout the globe for enterprises that are maybe based internationally. So in that case, we're working toward that, but we just quite candidly, our infrastructure is all within the U.S. today.
Thank you, Chris. And the final question, as far as I can see, is about the performance. A lot of companies are advertising that they can achieve a high speed of up to 100 gigabytes per day. and that's clearly not acceptable for data sets over 1 terabyte with any decent rate of incremental change. So how do you handle, is it practical to update, to backup online data sets over 1 terabyte?
It is, but that is actually a key question to ask. I said earlier that security, by and large, cloud-based companies, the security stuff is table stakes, and there's little room to differentiate there. In contrast to that, though, performance is actually something that should be something you focus on a lot if you're evaluating cloud backup providers. And the reason for that is this. If you were a company who started out as a packaged software backup application and you tried to bolt it onto the cloud, you would struggle, because the notion is that the data sets that you're creating never contemplated the internet as the data conduit that you pass them through, so they tend to be too large. So a lot of those companies move to the appliance form factor to be able to stream something to a local appliance and then trickle it off to the cloud. Similarly, if you are a cloud backup provider that was initially conceived of for consumer data sets, a 15 gig on a laptop kind of thing or even less, those solutions typically weren't built with the idea that a single server might have 4 or 5 terabytes on it that needed to be protected. The Zetta solution was built almost backwards. We started with by creating a bunch of technologies that would make us very optimized for internet data transfer. Our engineering staff comes from Netscape, and they have a lot of deep knowledge in how to make the internet work most efficiently. And all of our patents that we have pending on our technologies happen to be on the WAN optimizing technologies that we put in place. And that, I won't go too far into the details, but there's a combination of minimizing the amount of data that must be moved over the internet, as well as using the internet as efficiently as possible to move the data that does need to be moved. And we've seen people achieve 4 to 5 terabytes or more in and out of our cloud on a given day. Now, those are obviously companies that have large pipes on their end, and we have large pipes on ours. But even somebody who's got 10 or 100 megabits per second can achieve very large throughput. So what we like to think at Zetta is that we've opened up a segment of the market that might have 1, 2, 5, 10, 50 terabytes of data they want to protect using a cloud-based service. And the existing solutions and approaches really don't accommodate data sets that are that large.
Thank you, Chris. And it looks like there are no more questions. So again, thanks our presenters today, and thank you all for listening. Please feel free to contact us via phone or email, or please feel free to start a trial. It's an unlimited trial for 15 days where you can actually witness yourself how fast is the backup, will it work for you, and how good or how suitable it is in your environment. On that note, thank you and have a great weekend.